Good morning. For the subject Big Data Analytics, Unit 3 comprises of majorly NoSQL databases and MongoDB. And from the exam point of view, these are few of the important questions like why we need NoSQL, gap theorem, comparison of SQL and NoSQL, architecture of MongoDB, MongoDB data manipulation operations. So these questions and answers discussion will be there in today's session, which will help us in preparing for the exam. Let us look at differences between SQL and NoSQL databases. SQL databases are relational databases. Data is in the form of tables with rows and columns, while NoSQL databases are non-relational databases, which are capable of handling large volume of structured, semi-structured, and structured data. In SQL, schema is fixed, while in NoSQL it is flexible. SQL data models are relational, while NoSQL are either key value based or document based or column family or graph models. In SQL, scalability is vertical, while in NoSQL scalability is horizontal. SQL follows ACID properties, while NoSQL follows base properties. Base stands for basically available and eventually consistent. SQL uses SQL, while NoSQL uses different types of query languages. Examples for SQL are MySQL, Oracle, while for NoSQL are MongoDB, Cassandra, HBase, Redis. SQL is suited for queries and transactions, while NoSQL is suited for big data applications, distributed systems, real-time web applications. Coming to CAP theorem, there are three letters CAP, which stands for consistency, availability, and partition tolerance. CAP theorem was given by Eric Brewer, which states that a distributed database can guarantee any two of the below, not all the three at one. So, and in this P, there is partition tolerance for big data application is compulsory. So the combinations can be CP, that is consistency, and partition tolerance, or AP, availability and partition tolerance. Consistency, what it indicates that same data will be retrieved in the distributed system. Example can be in a bank, account balance must be same across all the servers. Availability means every request will be receiving a response, even if some nodes in the system fail. The system remains operational at all times. Users always get a response. Partition tolerance indicates the system continues to operate even if network failure occurs between nodes. Data is distributed across multiple servers. If communication fails among the servers, the system still works. So again, there is a comparison of SQL and NoSQL databases, which is on similar lines. Coming to the next question, MongoDB command for creating and dropping a database. For that, we'll be using use college db command, and to drop a database, we'll be using drop database. The next question is, what is NoSQL? Why NoSQLs are required in big data applications? NoSQL stands for not only SQL. These are non-relational databases. They'll be storing large volumes of structured, unstructured, semi-structured, which are rapidly changing data. They don't have a fixed schema, and the formats can be key value based or document based or columnar or graph based. Examples can be MongoDB, Cassandra, HBase, CosDB. They are suited for distributed computing ecosystem where high scalability, availability, and performance is desired and given. NoSQLs are required in big data application because it has to handle large volumes of data, that is terabytes or petabytes of data. Horizontal scaling is required, meaning data is distributed across many servers or clusters. Flexible schema is supported, which is a dynamic schema. High availability and fault tolerance is there. Fast data processing is there. Support for distributed ecosystem is there. We can handle these different types of data. Coming to the next question, what is columnar database? It's a NoSQL database. It stores data column by column instead of row by row, which happens in our traditional SQL. Columnar databases are suitable for big data analytics and data warehousing. What are the advantages? Faster data retrieval for analytical queries, efficient storage and compression, handles large scale distributed ecosystem. So example of columnar database is Apache Sbase or Cassandra. Similar question. Coming to types of NoSQL data models, they basically are of four types, or four data models are there. One is key value store. Okay, so here each key is unique and retrieves a corresponding value. They are suitable for caching, session management, simple recourse. Examples can be Redis, Amazon, DynamoDB. So here the key is ID and values are this. The other data model is document store. The formats used are JSON or BSON. They have flexible schema. They are suitable for content management and web applications. Examples are MongoDB and PowerDB. So this is the way the data will be stored. Coming to column family store, the data is stored in columns instead of rows. They are suitable for large-scale data analytics. Apache HBase and Cassandra are the examples. The next data model is graph database. Example is Neo4j. Here nodes are entities and edges are the relationships. This is the architecture and working mechanism of MongoDB. So it is NoSQL, document-oriented, JSON, BSON-based, offers high performance, scalability, flexibility, suited for big data, modern web applications. This is how your architecture looks like. So you have application, driver sitting at one place, then your routers, then you have a replica set, then where these are the shards. You can see the shards here. So you have the Mongos and the Mongo shell. This MongoDB is running. Now, if you look at the MongoDB architecture, it is a document model and the components are database. Database here is a container that has collections, and collections are equivalent to tables in SQL. Then collections have documents which are equal to records in SQL. Then you also have a replica set, which is a group of MongoDB servers that maintain the same data to ensure high availability and fault tolerance. So here you have primary node, secondary node, and the arbitrary. Coming to the word sharding, which indicates distribution of large data sets across multiple servers to offer horizontal scalability. Here you have component shard, config server, Mongo's routers. Here the config server will be storing the metadata about the cluster. Mongo's router will be directing the queries to the correct shard. So what the working mechanism of MongoDB? So a client requests a query to the MongoDB server using drivers like Python, Java, Node.js. MongoDB server processes the requests. The data is stored in collection as JSON documents. MongoDB creates indexes for search operations. Replication is used for availability. Sharding also is used to split the data on multiple records. Queries are routed using Mongos. These are the advantages of MongoDB: schema flexibility, high scalability, high performance, high availability, rich query language, big data support. What is the setup for MongoDB is you need to download MongoDB, install MongoDB, create a data directory, start the MongoDB server using this command MongoD, open the terminal and run the shell Mongo. Then you can check the installation by creating a database using the use command, insert records. Data manipulation operations indicates CRUD operations: create, read, update, and delete. If I want to insert, I'll be using the command insert one or insert many. If I want to find operation perform, I'll be giving the command using find. This is the example: db.student.find course AI. Update operations, for that you'll be using update one or update many in the syntax, and you'll be using the parameter $set for making the updates. For delete, deleting the documents, you'll be using either delete one or delete many. Thank you.